All right, y'all. So today we're gonna start with a warm up from yesterday, and then or like a do now problem that relates to yesterday, and then we'll do some warm up problems for today. Okay, so factor 6x squared minus 24x and find the sum of its roots. So the first thing we need to do is factor this. So that's what we're gonna focus on first. Even if you don't know what the second part of a problem means, always focus on the first part. So to factor this, we are gonna take out a GCF. So what is the largest number that goes into 6 and 24? That would be 6. And then the smallest number of x's that we could take away is 1x. So that's the GCF. Now we need to do division. We started with 6, divided by 6 gives us 1. And then we do subtraction with the x's. So we started with 2 x's, we took away 1x. 2 minus 1 is 1x is left. Bring down your minus sign. Then we do 24 divided by 6, that gives us 4. And then we started with 1x. We take away 1x, we get no x's. All right, and I'm going to simplify this. We do not need this one. We don't need that one because it's multiplication and that's an exponent. So we have 6x, x minus 4. Okay, those are our two factors. Now that we've done that part of the problem, we can focus on find the sum and then of its roots. So one thing that should sound familiar is roots. We did zeros, solutions, x-intercepts, roots yesterday. So we're going to start with finding the roots. We do that by setting 6x equal to 0, setting x minus 4 equal to 0, and solving for x. So here we're going to divide by 6 on both sides, x equals 0, plus 4 on both sides, x equals 4. So those are the roots, but we have not fully solved this problem because it says find the sum of the roots. Sum means addition. So if you don't know that, put that in your notes. Sum means addition. So we need to add the roots. So we're going to do 4 plus 0. 4 plus 0 equals 4. Your answer to this problem is 4. This is an SAT style problem. Sometimes they'll ask you to factor and then do something with the roots. So that's why we found the sum. Okay, next, we are going to practice finding the product. Product means multiplication, another important word for SAT. So product, we are going to do that using the area model. You may, oh, sorry, my box is not big enough. You may have remembered using the area model from last year. You put the things that you're multiplying on the outside, and then you put the multiplication part on the inside. So we have x times x, x squared, x times 3, 3x, 7 times x, 7x, 7 times 3, 21. Now we need to write the whole thing out, x squared, and then remember we add the diagonals. So 7 plus 3, that gives us 10, and then x on that, plus 21, because that's our last term. There is the product. And then it asks us to do the same thing here. So we're going to draw a box. Again, put x plus 3, x minus 7, and find the product. X squared, x times x is x squared, x times 3 is 3x. Negative 7 times x is negative 7x. Negative 7 times positive 3 is negative 21. Make sure you got those negatives correct. Now we need to combine them. X squared, add the diagonals. Negative 7 plus 3x is the same as saying 3 minus 7. 3x minus 7x. So 3 minus 7 is negative 4x minus 21. That is the product. And then we're going to go down here really quick. True or false? This side, x plus 4 times x minus 2 is equal to x squared plus 2x minus 8. How could we figure out if that was true or false? Multiply. Multiply. Actually do the multiplication. So if you do the multiplication using the box, over here, do you get the same thing? And there's a reason we're practicing using the box so much. It's going to be important for today. So x plus 4, x minus 2. we get x squared, negative 2x, 4x, and then negative 8. That gives us x squared. If we combine these, it's 4 minus 2 plus 2x minus 8. Check it out. We multiplied these, and we got this, which is the same thing. So, true. These are the same. All three, same thing. Okay, and then for this one, we're not going to do the full thing because we're actually going to do that today in notes, but I will tell you what the full answer is in case you remembered how to do the full thing. But hopefully everyone got the GCF. If you did not get it, really quick, get the GCF and tell me what it is. Okay, so for GCF, in this thing, we should have looked what number can go into 2, 8, and 42. The GCF is 2. They do not all have x's, so your GCF does not have an x. And then you would have gotten 2 divided by 2 is 1. So all that's left there is x squared. Negative 8 divided by 2 is negative 4. X, because we didn't take any x's out. Negative 42 divided by 2 is negative 21. Make sure you remember to check your signs. Negative, negative. All right, and then if you fully factor this and you want to know what the fully factored form is, I will give that to you. It is 2, that is a factor, x plus 3, and then x minus 7. Okay, so let's move on to notes. And again, you should have your notebook out and ready to go when we're doing the do now review. You should be like taking some notes then. All right, now we're going to do notes. So write down 0.2 notes. 0.2 notes factoring quadratics. And we're going to remember what is standard form of a quadratic. You should be able to write this based on what we did yesterday. Try to remember, write it down if you know it, and now check it. Ax squared plus bx plus c. And usually quadratics are equal to 0. We want to set them equal to 0. That's the standard form. All right, when factoring a quadratic, what should you always check for first? What did we do yesterday? Greatest common factor. So write that down. That's important. Always check for a GCF first, a greatest common factor first. All right, and now let's go ahead and factor a quadratic trinomial. That means a quadratic with 3 pieces using the box. So this may not be how y'all factored last year, but it's going to be very similar, and I just want you to try it because I think you're going to really like it. So first things first, we're going to check for a GCF, just like we wrote here. So first, we're factoring this function. Does it have a GCF? Yes. What can go into all 3 of those numbers? 2. So I'm going to put the GCF 2 out here, parentheses, and now we write what's left. 2 divided by 2 is 1. We don't need to write the 1, so we have x squared plus 2 divided by 2 is 1 again. We don't need to write the 1, so we just write the x minus 24 divided by 2 is 12. Okay, cool. Now that we've written the GCF, we're going to do this step where we write A, B, and C. So what does A equal? Now that we're looking here, we're going to factor this thing. So what does A equal? 1. What does B equal? What number is on this x? 1. And then what does C equal? Don't forget to take the sign. Negative 12. Okay. And now, here's how I teach factoring. It's very similar to how previous teachers probably taught it. We're going to figure out what multiplies to A times C. So like write this down when you're factoring. What multiplies to A times C? And we're going to put it in, and then we'll write A times C. Then we'll figure out what adds to B. And when we say A, B, and C, we're talking about these things. So we'll put it A, and we'll say adds to B. And we will use the box, the area model, to factor this. So I'm going to draw a box, and actually I'll stay with blue. Trying to factor this thing, okay? Just this piece. The 2 will bring down at the very end. All right, so I'm going to draw a box. and we need to multiply to A, that's 1, times C, that's negative 12. So 1 times negative 12, we need to multiply to negative 12. Then we need to add to B. My B value is 1. All right, now we have to come up with numbers that multiply to negative 12 and add to 1. What I like to do a lot of the time is just draw like a little table if I'm struggling. What can multiply to 12? 6 and 2? Any way that those can combine to make 1? No. 12 and 1? But those can't add up to make 1. What about 3 and 4? Those are only 1 apart, so they can combine to make 1. Which one needs to be negative? The 3. 4 plus negative 3 gives me 1. All right, so here are our numbers that we need to use, negative 3 and 4. And let's talk about how we fill out the box. You will always take this term and put it in this square. And then you will always take this term with the sign and put it in this square, always. So let's go ahead and do that. We have x squared here and negative 12 here. Okay, and then we can take these numbers that we got that multiply and add to the right thing, and they can go here. You can put them anywhere you want. They can switch sides, whatever you want. Doesn't matter which one you use. So I'm going to put the negative 3 here and put an x on it. Always put an x on them. 4 is going to go here. I'm going to put an x on it. Okay, so now that we've got the box filled out on the inside, here's what we're going to do. We are going to do a GCF with these to figure out what goes on the outside. So what is the GCF between x squared and 4x? That's going to go here. What do they have in common? They both have x. What is the GCF between negative 3x and negative 12? That's going to go out here. Well, both of these numbers have negatives on them. And then 3 can go into 3 and 3 can go into 12. Do they both have x's? No. So this is the GCF, just negative 3. All right, now we're going to do the same thing going up. What does the negative 3x and the x squared have in common? Sorry. Negative 3x and x squared both have x's. What about going up this way? 4x and negative 12. They both can be divided by 4. So your factors are here. X minus 3, x plus 4. So let's write that down. X minus 3. You always need to write your factors like this, in parentheses next to each other. And then we may be forgetting one little thing that we did in the very beginning. The first factor we found, the GCF, that needs to come down at the end and go in front. So here are all of our factors. We have 3 factors. 1, 2, 3. What about finding the zeros? To find the zeros, remember you set each factor equal to 0. Now, can we set 2 equal to 0? Does 2 equal 0? No. If it had an x there, we could solve for x, but we can't solve for x here, so don't worry about it. That's not going to have a solution. But we can set x minus 3 equal to 0 and x plus 4 equal to 0. So x minus 3 equals 0. What would x equal? X plus 4 equals 0. What would x equal? Give me the 2 solutions to this problem. Okay, so we do plus 3, that cancels. We get x equals 0 plus 3, which is 3. That's one solution. We do minus 4, those cancel. We get x equals 0 minus 4 is negative 4. That's the second solution. Sweet. So you need to know how to find the factors. You need to know how to get here. And you also need to know how to find the solutions. All right. We're going to do another problem. I want you to try this one on your own. But first, what looks different about this one? Is it in standard form? No, it's not. So let's make sure we get it in standard form first. We need to move something over. We always want this thing to stay positive. Is it positive right now? Yes, it is. So that means leave it there. Leave it on that side. Move everything else. So we're going to do plus 17x opposite signs, right? Inverse operations, plus 6, plus 17x, plus 6. Okay, cool. So now let's really quick write what we got. These cancel and make 0. And I'm going to write down here we have 5x squared plus 17x plus 6. Now we are in standard form. I want you to try to use the box to factor this thing in the same way that I did. So, tell me, what factors do you get? Go. Okay, so now that you've tried, I know this one was harder. This one was like a lot harder. I don't know if y'all noticed. Hopefully you noticed. It's okay if you didn't get it. I wanted you to try. I hope that you did try and that you tried your best. So we're always going to start by drawing the box. Actually, we're going to start by doing a GCF. Do these numbers have anything in common? We cannot divide any of these numbers by the same number. So there is no GCF this time. So we're good. We're good to start with the box and the A times C and the B thing. So we need to multiply to A times C. That's the first term times the last term. So what's 5 times 6? 5 times 6 is 30. We need to multiply to 30, and then we need to add to B, which is positive 17. Add to 17. These numbers are hard. Multiply to 30, add to 17. I'm going to make my table. What multiplies to 30? 10 and 3? Can those add up to 17? Nah. What else multiplies to 30? 6 and 5. Can those add up to 17? No. What other numbers multiply to 30? Give me in the chat box what can multiply to 30. Okay. You hopefully got to 15 and 2. That one was really hard, y'all, because they were big numbers, 15 and 2. So, again, the 15 and the 2, they can add to 17. So, those are going to go in these spots. So, let's go ahead and put 15 and 2 in there. 15, and what do we need to put on them? X. 2x. All right, and then these, again, 5x squared is going to go in the first box. And what color did I use? I don't remember what color I used. 6 goes in the second box. So let's go ahead and throw those in there. 5x squared, 6. And now we pull out a GCF. So let's pull out a GCF. What do these have in common? 5x squared and 2x. 5x squared and 2x both have x. We're going this way. All right, what about this one? 6 and 15x. Those can both be divided by 3. What about going up? These 15x and 5x squared both have x in common. They can also both be divided by, the biggest number that they can be divided by is 5. In this way, the number that this 2 and 6 have in common, the biggest number is 2. Those are your factors. We have 5x plus 2 and x plus 3. All right, I want you to find the solutions, the zeros, the roots, the x-intercepts. Go. Okay, you should have set, this one was a little trickier, you should have set each one of these equal to 0 and solve for x. So for this one, we have to do the addition subtraction first. You do the thing that's furthest away from x first. You get 5x equals 0 minus 2 is negative 2. Then your next step is to divide by 5, inverse operations. X equals negative 2 divided by 5. That is your first solution. Then we need to do inverse operations to get x alone over here. Add 3. 0 plus 3 is 3. That's your second solution. All right, make sure you know the difference between factors, and in blue we have, these are called solutions. Write that down. X-intercepts. I'm going to call them x-ints, roots, or zeros. Those are all the same thing. Okay, now we're going to do some practice. Good job with that fast, speedy section of notes.